Welcome back to Science Mordernizers. Welcome back to our channel. Welcome back to this video. Today we are going to solve the aptitude medical entrance examination, the physics 2020 session, that is the entrance exams into medical schools in Cameroon. As we observe on the screen, we see Objective Corporation. Objective Corporation is a national preparatory center and is one of our official partners, which prepares students to go in for national competitive entrance examinations in Cameroon. They have been existing for the past 10 years and they have outstanding results so long as preparing students and having students in professional schools in Cameroon is concerned. So with that, let's get started with the video and stay tuned. Okay, so let's get started with the video. So the very first question says the SI unit of work done on an object is A, B, C, D, E. So the work done on an object is given by W and is equal to the force times the distance moved in the direction of the force. So we have the force is given by the mass times the acceleration according to Newton's second law times the distance marked. The unit of M is the kilogram. The unit of acceleration is the meters per second squared times the unit of distance, which is the meters. So at the end we get the meters times the meters gives meter squared. So we have kilogram meter squared seconds per second square. So this is also equivalent to the kilogram meter square per second square. So the correct option is option A. Okay, let's go to the second question. So the second question reads, which of the following physical quantities are all scalars? A, weight, B, temperature, C, mass, B, weight, displacement, speed, C, weight, energy, momentum, D, force, displacement, velocity, E, none of the above. Now we know that a vector quantity is a quantity which has both magnitude and direction. So mass has only size, it has only size. So option A is not made up only of scalar quantities, because we have this option, the weight. The weight is a force, W, which is a vector quantity. It has a direction. So we get anywhere we see weight is already eliminated. So which of the physical quantities are all scalars? So the correct option is none of the above, because weight is a vector quantity, momentum is a vector quantity, velocity is a vector quantity, displacement is a vector quantity. So none of the above are all scalar quantities. So the option here which also defines physical quantities which are all vector quantities is option D. So if they asked you about vector quantities, they are simply quantities which have both magnitude and direction, and option D is that. But for scalar quantities we get none of the above. So none of them represent only scalars. Question number 3. So the correct option for this is E. Question number 3. Which of the following affirmations concerning a body in motion is not correct? Is not correct. A. Each time the speed of a body changes, its velocity also changes. It is a true statement because speed is the magnitude of velocity. So it means that if I have changes in speed, then my velocity will definitely have to be changing in one way or the other, because velocity has direction and speed has only size. So speed is the magnitude of velocity. So this option is correct. Next, if the body has a constant speed, it is possible for it to have an acceleration. This option too is correct. On the case of circular motion, when the body is moving in a circular path, it has an acceleration called the centripetal acceleration, but throughout all of its motion it is moving at constant speed, and the direction of the velocity is always directed, or is always a tangent to the circle at all points. Let's proceed. So that option 2 is correct. Option C. If it was brought to rest, it is not possible for it to start moving if the resultant force is null. Correct. According to Newton's first law of motion, a body at rest will continue to be in a state of rest, and the body moving with uniform velocity will continue to move in that state unless an external force acts on it. So that option is correct. Option D. Even without acceleration, it is possible for a body to change its speed, so this is the wrong option. Once your speed changes, acceleration changes because the velocity will change actually, so the correct option here is D. So question number 4. A block X of mass 30 kg is accelerated from rest by a force of 5 Newton during 2 seconds. An identical block is accelerated by a force of 5 Newton during 4 seconds. The ratio of the kinetic energy of X to the kinetic energy of Y after acceleration is dash. So for block X, so we are going to calculate their respective energies separately. Now for block X, kinetic energy Ke is equal to a half mv squared. So since we are beginning from an initial state to a final state, we are going to use the change in the speed. So the change in the speed will be the final speed squared minus the initial speed squared. But as stated in the question, they were all at an initial speed of 0. So it started at rest, so u is equal to 0. So we are going to use Ke will simply be equal to a half mv squared. A half mv squared. So we have to get the expression of the speed of X and the speed of Y respectively in order for us to calculate their kinetic energies using the information that was given to us. So the very first information that was given is the mass, the force, and the duration with which the force caused the object to move. So from the definition of a force, thus the force is the mass times the rate of change of velocity, that's delta v divided by t, and this delta v on t is equivalent to the acceleration. So we have mv divided by t, since the initial speed is 0. So from there we can get the value of the speed. So v of x will be equal to the force acting on x times t divided by the mass. So we get v of x, the force has a value of 5 Newton, that's 5 times the time, which is 2 seconds, divided by the mass. The mass is 3 kg. So this gives us 10 divided by 3 meters per second. Now we are going to do same for y. So for y, the speed of y will simply be given by the force Fy times t divided by the mass of y. So here is the mass of x. So we collect the data. So we have a 5 Newton force, duration of 4 seconds. So 5 and an identical, so it means their masses are the same. So we get 5 times the duration of 4 seconds divided by the mass 3. So this gives 20 divided by 3 meters per second squared. So meters per second. Now we get the expression of the kinetic energy. So the kinetic energy of x will be equal to a half the mass of x is 3 times the square of the speed, which is 10 divided by 3, all of that squared. And when we simplify, we get a half into 3 into 100 divided by 9. So 3 can simplify 2, and here it goes on to 100 50 times. So I get 50 divided by 3. So here we have 50 divided by 3 joules. So for y, we are going to calculate the kinetic energy of y. So it is going to be a half identical mass 3 speed squared 20 divided by 3, all of that squared, and this gives me 3 all over 2 times 20 squared is 400 divided by 9. 3 simplifies with this, and this goes 200. So we have 200 divided by 3. So from there we can calculate, we have to calculate the ratio of the kinetic energy of x to that of y. So Ke of x ke of x divided by ke of y will be equal to 50 divided by 3 divided by 200 on 3. So we get 50 on 3 times 3 on 200. This simplifies with this goes 1 here 4 times, so the correct option is 1 over 4. In ratio form is 1:4, so we take the correct option. So the correct option is option C. Okay, question number 6. Since an electron carries a charge of magnitude 1.6 times 10 to the negative 19 coulomb, how many electrons per second cross a conductor when it carries a current of 1.0 milliampere? So we are simply going to use the relation between charge and current. Q is equal to IT, which is equal to ME. So we are looking for the number of electrons per second, that's N all over T. N all over 2 will be equal to I divided by the electronic charge, and I is given by 1 milliampere. That will be 1 times 10 to the negative 3 amperes divided by the electronic charge, which is 1.6 times 10 raised to the negative 19. So if 19 goes up, if 19 goes on the numerator, we get 1 divided by 1.6 times 10 to the negative 3 plus 19. So 1 divided by 1.6 gives 0.625. So here we have 0.625 times 10 raised to the 19 minus 3 is power 15. And so if you rearrange, this will be equivalent to 6.25 times 10 raised to the power 15. So the correct option would be B. Correct option is B. Now we go to the next question. Question number 6. So question 6 reads, the length per unit resistance of a copper wire has value 7.6 millimeters per ohm with a diameter of 1.45 millimeters. This corresponds to a resistivity of. Now the resistivity of a material raw is given by the resistance times the cross-sectional area of the material divided by the length of the wire. So we get that we are looking for the resistivity, and we know the length per unit resistance, so L divided by R is given to be 7.63 millimeters per ohm. So we can simplify this in SI units, so that will be 7.63 times 10 to the negative 3 meters per ohm. So from there we can get the value, from here we can get the value of L divided by R. So L on R is 7.63 divided by that, and so the resistivity raw will be equal to, so we have R all over L. So R all over L is 1 divided by L all over R, all of this times the cross-sectional area A, and the cross-sectional area of the wire is given by pi diameter squared divided by 4, and the diameter was given to be 1.45 millimeters. And so the cross-sectional area of the wire A will be equal to pi to 1.45 millimeters times 10 to the negative 3, all of that squared in SI units divided by 4. So the numerical application for that gives, that's a 1.45 times 10 raised to the negative 3, all of that squared multiplied by pi and divided by 4. So we have a cross-sectional area of 1.65 7.65 times 10 to the negative 6 meter square. In most cases, it is better for us to do everything and apply and do the numerical application so that we can have the exact answer amongst the options. So now let's calculate the resistivity. So the resistivity rho will be equal to 1 divided by the length per unit resistance is 7.63 times 10 to the negative 3. So I'll replace it here. 7.63 times 10 to the negative 3 times the cross-sectional area. I will write it the way it is into 1.45 times 10 to the negative 3, all of that squared. So this permits, this also reduces errors and approximation errors, so that if answers are too close to each other, this one will give you the exact value. So we are going to punch this. So the cross-sectional area, that will be divided by, when you punch everything, you have 7 times 10. So the final result for the resistivity, it gives 2.164 times 10 raised to the negative 4, and the unit of the resistivity is meter. So let's check if you have an option like that. 2.16 times 10 to the negative 4. So the correct option is option A. Okay, let's continue with question 7. Question 7 reads, an ideal gas dilates in an isothermal manner and absorbs a quantity of thermal energy equal to 500 joules. The amount of work done during the expansion is, so we are going to use the first law of thermodynamics. Now the first law of thermodynamics says the variation in internal energy delta U is equal to the amount of heat plus the work done. Now we see that it is under an isothermal condition, and under isothermal conditions the internal energy is constant, and so the variation of the internal energy will be equal to 0. And from here we get that the work done will simply be equal to negative Q, which will be negative 500 joules. So the correct option is option D. Question number 8. A sample of gas of volume 1.5 times 10 to the 5 meters cube at a pressure of 3 times 10 to the 5 pascals. What is the new volume when the pressure is reduced by half a constant at constant temperature? So we can apply the gas laws, and most especially the Boyle's law, where we have that the pressure is inversely related to the volume, and so since we are under isothermal conditions, we can get that PV is equal to a constant K. So from here we have P1 V1 is equal to P2 V2. Now we are going to define our P1 is 3 times 10 raised to the power 5 pascal at a volume V1, which is 1.5 times 10 to the power 5 meter cube. So here, what is the new volume when the pressure has been reduced to half, has been reduced by half at constant temperature? So it means P2 is simply given by P1 divided by 2. So let's replace and get the value of the new volume V2. So we get V2 will be equal to P1 V1 divided by P2. So we can replace P2 by P1 divided by P2. So we get P1 V1 divided by P1 all over P2, which is going to give 2 P1 V1 on P1. So the P1 will simplify. So P1 will simplify. It means V2 will simply be equal to 2V1. And so from here we get that V2 will be equal to 2 into 1.5 times 10 raised to the power 5, and this gives us 3 times 10 to the power 5 meter So the correct option is C. Okay, so let's proceed to question number 9. So question number 9 is, which of the following affirmation on potential energy and the force between two molecules is not true? So the potent is the potential energy and the force turns to zero at infinity is true. So the expression of the potential U is given by constant A divided by R raised to the power 6 minus B divided by R raised to the power 12, and the force F is simply negative the derivative of the potential with respect to R. So you see that when we differentiate this from the function U, we are still going to have a function in which the denominator will be higher than the numerator, and so if we set R to the infinity, both of them will tend to 0. B says the potential energy is lowest at the equilibrium position. It is a correct option. Then option C, does that. Option C says the potential energy and the force are equal at equilibrium separation. So that's not true. At equilibrium separation, it is the resultant force or the net force that is equal to 0. So that particular option is not true. This particular option is not true. D says at equilibrium separation, the force between the two molecules is 0. So that it is correct. None of the above. So the correct option there is C. So C is not true. Question number 10. Question 10 reads, the height at which a liquid rises in a capillary tube with an open extremity due to surface tension depends on. So the capillary rise H is given by 2 gamma cos theta. All of this is divided by rho gr. All of this is divided by rho gr, where gamma is the surface tension, that is the force per unit length. So gamma is the surface tension. R is the inner radius of the tube. Inner radius of the tube, and theta is the angle of contact. G is the acceleration due to gravity, and rho is the density of the liquid. So checking the options, which one does the capillary rise depend on? So we see that it depends on the radius of the tube, and more specifically the inner radius of the tube. So the correct option is A. Okay, so we are going to proceed with question number 11. It reads, question number 11 reads, what's the electric force at mid-distance between two particles carrying each a charge of 2? So from the source of my question, the question is incomplete. The question is incomplete. So definitely, in order for us to get the expression of the force F will be given by K cure 1, cure 2, all of that divided by R squared. And so when you know the separation distance and you know the value of the two charges, then we can get the force, and it is amongst the options. So let's go to the next question. So I don't have enough information to answer the question from the source where the question was taken. The question was incomplete, so there is a continuation to this question. Question number 12. The nucleus of a transformer is laminated too. So the reason why the nucleus of a transformer is laminated, it is simply to reduce AC currents and to also improve the efficiency. So the only option that ties with it here, the correct option is option C, reduce the loss of AC currents. Question number 13. The resultant capacitance of a combination in series of capacitors of capacitance is 8 microfarad, 16 microfarad and 32 microfarad is, for capacitance in series, the equivalent capacitance C1 over C equivalent is equal to the sum as I runs from 1 right up to, we have 3, so right up to n in general, of 1 divided by Ci. So here our N is equal to 3. So the 1 over the equivalent capacitance C equivalent will be equal to 1 divided by the capacitance of the first, which is 8, plus 1 on 16 plus 1 on 32. So we can write this in a simpler form. So it means 1 all over C equivalent can be 1 all over 8 can be written as 4 divided by 32 plus 1 over 16 can be written as 2 divided by 32 plus 1 divided by 32. Since they all have a common denominator, we simply sum the numerators. That will be 4 plus 2 plus 1, which is 7 divided by 32. So 7 divided by 32 gives 0.218 farad. So there is no correct option. So the best option here could be option B. So I think with respect to the source, when the questions were being typed, this was solely omitted, in which here we had to get a 7 on 32. So we'll correct the option here, and the correct option will be B. In entrance exams, they rarely make such mistakes. So due to the source, they omitted the slash, so the correct option will be option B. Question number 15. Okay, so we are going to proceed with question number 14. Question number 14 says the energy stored in the capacitor of capacitance 10 microfarads carrying a charge of 100 microcoulomb is off. So E is equal to a half CV squared, which can also be simplified to a half Q squared divided by the capacitance, since we have the capacitance and the charge. So this means E will be equal to a half times the charge squared, that's 100 micro, times 10 to the negative 6. So I'm going to square this, all of that squared, divided by the capacitance. The capacitance is 10 microfarad, so that's 10 times 10 to the negative 6. So simplifying, we get E to be equal to a half. We have 100 square, that's 10 raised to the power 4, 10,000 times 10 to the negative 6 all square, that will be 10 to the negative 12, divided by 10 to the negative 5. When negative 5 goes up, it sums up to this 4, which becomes 9, and 9 minus 12 will give us 10 to the negative 3, and a half is 0.5, so it means our result will be 0.5 times 10 to the negative 3, which when simplifying gives 5 times 10 to the negative 4 joules. So the correct option is C. Question number 15 reads, which of the following declaration is a property of a uniform electric field? E. The electric field produces a force on a moving particle which is always perpendicular to the direction of displacement of the particle. Not necessarily true, not always. Next, the field produces no force on the charged particle at rest. C. The electric potential has the same value at all points in the field. D. The electric field strength is the same at all points. E. None of the above. So the correct option is option D. The electric field strength is the same in all points. Question number 16. If the number of turns of a solenoid are doubled without changing its length, the self-inductance of the solenoid will be, so the relationship between the length and the number of turns will be, sorry, the inductance L, the self-inductance L is related to the length by and the number of turns by n squared times the permeability A times the area, the surface area A divided by L. So we have said that the length is kept constant, So if I make L the subject, we want to see how doubling the number of turns, as I said, the number of turns doubling the number of turns. Let's see how it's going to affect the inductance. So if we keep mu A divided by L constant, so it means L will be equal to Kn squared. So I'm going to define it to be my L naught. So with that being as L naught, we can get now the new value of L. So from here, if we say L naught is equal to K n naught square. Now when n is equal to 2n naught, we are going to have the new inductance, capital L, will be equal to K into 2n naught, all of that square, which is going to be 4K n naught square. So we get that L will be equal to 4, but K n naught square is L naught, so before L naught. So the correct option is it quadruples. So answer E. When the voltage, question 16, when the voltage of an alternating current is applied to a capacitor, no power is used up because the current A and the voltage are out of phase by 180 degrees. B, current and the voltage are in phase. C is lagging the voltage by 90 degrees. D is leading the voltage by 90 degrees. E, none of the above. 90 degrees. Okay, so we get that the current in a purely capacitive circuit, IC, is simply given by I naught sine omega t plus pi on 2. So in purely capacitive circuits, the current leads the voltage, the current I leads the voltage by an angle of pi on 2. So the correct option is D. Question number 17. The energy stored in an inductor of inductance 5 millihenry when the current of 6 ampere is crossing it is, so the energy E is given by a half Li square. So we get a half into L, the inductance 5 millihenry, that's 5 times 10 to the negative 3, then times the current square, that's 6 squared. So we get a half times 5 times 10 to the negative 3 times 36. So 36 divided by 2 is 18, and 18 times 5 is 90. So that gives me 90 times 10 to the negative 3, which is 9 times 10 to the negative 2 joules. The correct option is T. Okay, so we're going to proceed with question number 18. It reads, at which frequency an inductor of 10 henries will have a reactance of 2000 ohms? So we are going to use the relationship XL, that's the inductive reactance, is equal to omega L, where omega is the angular frequency and omega is expressed in terms of the frequency as 2 pi f times the inductance. So we are looking for the frequency, so the frequency will be equal to the inductive reactance divided by 2 pi L. So numerical application yields, we have F will be equal to XL is 2000 divided by 2 pi L times 10. 10 and 10 will simplify, so goes here 1, here 100. So F will be equal to 100 divided by pi hertz. So the correct option is option C. Question number 19. An isolated sphere has a positive charge on its surface. Which of the following assertions describe best the electric field lines out of the sphere? Okay, the very first option reads, an electric field is null out of the sphere, hence there is no electric field lines. Option B reads, There are a series of concentric circles with fares pointing anticlockwise. Option C reads, there are series of concentric circles with fare pointing clockwise. D, they are directed radially towards the exterior. E, none of the above answers is correct. So the correct option to this question is option D. So why is it actually option D? It is because when an isolated sphere has a positive charge on its surface, the electric field lines outside the sphere are directed radially towards the exterior. So this is definitely due to the fundamental principles of electrostatics, that electric field lines originate from positive charges and terminate on negative charges. So the correct option in these, amongst the options, the best that describes it is option D. So we are going to take option D to be the correct option. Question number 20. Which of the following affirmation concerns a particle of constant mass undergoing a uniform circular motion? Is not true. Which of the following affirmation concerning a particle of constant mass undergoing uniform circular motion is not true? A, the particle has a constant speed. B, a particle has a speed in constant evolution. C, the particle is submitted to a constant force. D, the particle has a kinetic energy in constant evolution. E, none of the above. So when we are moving in the circular path, what we have to understand is the speed of the particle remains unchanged. Therefore, we are going to move under the action of a constant force. And since the particle displaces itself in a closed path, then the total work done, that's the work done, will be equal to 0. So from here we get that the expression number, the first option A, which is the particle moves with constant speed, is true. But here we are saying which of the following affirmation concerns a particle of constant mass undergoing a uniform circular motion is not true. So I'm interested in not true. So this is true. Next, the particle has a speed in constant evolution. No, it does not have a speed in constant evolution. So this is wrong. The particle is subjected to a constant force. F is equal to mv squared divided by r. So the radius will not change, the mass does not change, and the speed is constant. So definitely it is subjected to a constant force. It's true. The particle has a kinetic energy in constant evolution. Kinetic energy is equal to a half mv squared, but the speed is constant, so it's impossible for this to be evoluting over time. And the next says none of the above. So there are two options in this question, in which we have option B and option D, which are wrong. So those are the answers to this particular question. Now in the whole, if you are obliged to choose one, choose one. Okay, question number 21 reads, the period of a simple pendulum is doubled when its length is increased by 0.6 meters. The original length of the pendulum is, okay, so we are going to use the expression of the period of oscillation of a simple pendulum. So I'm going to call the initial period T0, which is given by 2 pi times the square root of L0 divided by G. We'll call this equation 1. Now when the period is doubled, I'll call it T prime, which is equal to 2T0, which will be equal to 2 pi times the square root of L0 plus 0.6, all of that divided by G. So we now simplify. So simplifying, we get 2 and 2 will cancel out, so our T0 will be equal to pi times the square root of L0 plus 0.6, all of that divided by G. I will call this equation 2. So if you take equation 2 divided by equation 1, we will get T0 divided by T0 will be 1. 1 will be equal to pi divided by 2 pi. I will get a half times the square root so we are going to have it times the square root of L0 plus 0.6 divided by G that will be divided by the square root of L naught divided by G. So let's simplify the expression. So what I get is, what we get now is, it means 1 will be equal to a half into L naught plus 0.6, all of this divided by G, all that inside the square root, times the square root of G divided by L. So from the laws of indices, from the laws of sets, so we get a half into the square root of L naught plus 0.6, since they are all positive quantities, divided by the square root of G times the square root of G divided by the square root of L. So we'll do some cancellation. So the square root of G we cancel out with the square root of G, so these two we cancel out, so I'll be left, so this is L naught, omitted na 0, L naught, so it means 1 will be equal to a half times the square root of, there we have L naught plus 0.6 divided by L naught. So you can get the value of L naught from this equation. So if you square both sides, we will get 1 squared is 1 will be equal to a half squared, which is 1/4, times the square root of L naught plus 0.6 divided by L naught squared will simply give L naught plus 0.6 divided by L naught, and the right hand side is equivalent to L naught plus 0.6 divided by 4L naught. So simplifying, 4L naught can multiply 1, that's multiplying also by 4L naught. I will get 4L naught will be equal to L naught plus 0.6. So this means I have 4L naught minus L naught will be equal to 0.6. So this means I get 3L naught will be equal to 0.6, from where L naught will be equal to 0.6 divided by 3, which is 6 times 10 to the negative 1 divided by 3. So that will be 2. So that will be 2 times 10 to the negative 1. So the correct answer is 0.2 meters. 0.2 meters. So the correct option is B. So the next question is, which of the following affirmations is true? A thermometer is a device that permits to measure the quantity of heat lost by an object. Heat is a form of energy which is transferred solely due to a difference in temperature. Number C says a change in temperature is always produced when heat is exchanged between a body and the surrounding. D, two bodies of the same temperature exchange no heat. So they said which is true. So the correct option here is B. Heat is a form of energy which is transferred solely due to difference in temperature. Okay, question number 23. It reads, conduction, convection and radiation are methods of heat transfer. Which of the following affirmations is true concerning the methods of heat transfer? A, the transfer of energy by these processes require no material medium. B, energy moves up the temperature gradient in all the processes. C, energy moves down the temperature gradient in all the processes. D, these processes require a material medium. E, none of the above. So let's analyze the options. First option A, the transfer of energy by these processes require no material medium, is wrong. Only radiation does not require a material medium. B, energy moves up the temperature gradient in all processes. It's wrong. Energy always flows from the direction of higher temperatures to regions of lower temperatures. So this is not correct. C says energy moves down the temperature gradient in all the processes, is correct. So we are leaving from regions of higher temperature moving towards regions of lower temperature. So that option is correct. D. The processes require a material medium, unlike A, wrong. And E, since option C is correct, option E will not be correct, wrong. So the correct option is C. An ammeter, question 24. An ammeter of resistance 5 ohm has a full-scale deflection when the current of 50 milliamperes crosses it. The value of the resistance necessary to adapt it to measure a current of 5 amperes is. So the shunt resistance RS is simply given by the full-scale deflection current times the resistance of the metal divided by the desired full-scale deflection current minus the full-scale deflection of the metal, IFG. So RS will be equal to, IFG is 50 milliamperes, so that will be 50 times 10 to the negative 3 times the resistance of the metal, which is 5 ohms, divided by IFE, which is 5, minus 50 times 10 raised to the negative 3, and numerical application yields 0.05 ohms. So the correct option is C. Thanks for watching this video, and see you in the next video. Stay tuned, and more videos shall be uploaded in order to enhance our question answering in physics in the medical sector. Stay blessed, and see you in the next video.